Hello everyone and welcome to another video Special Maths Academy. In this video, we'll be looking at the problem from the previous video. So there was a slight mistake and I'm going to correct it. So basically, it has to do with the properties I stated. So the last property, okay? So the last property doesn't always hold. It holds when, so let's look at it. Yeah, so last property, GCD, X and V being equals to W, and so having these two, so I'm supposed to add another condition. So the GCD of W and Z should be equal to 1. And so that this holds. So when you have these three, 1, 2, 3, then we can conclude that GCD of X and VY will be equal to WZ. Okay. So I'll try and prove this. This is not exactly a basic property, so that's why I'm making a video to prove it. So the other properties are quite basic. So this is it's not really a basic property. So let's try and prove it. So I would basically just take it down here. Okay, so I'll write the statement below. Okay. So GCD of X and V being equal to W. GCD of X and Y being equal to Z. And then the GCD of W and Z being equal to 1. So we want to get that with the GCD of X and VY is equals to WZ. Okay, so let's look at this. So the GCD of V and X being equal to W means we can have something like this. So this statement implies that we can have X being equal to, say, X1 W, V equals to V1 W, and that the GCD of X1 and V1 are equal to 1. Okay. And similar thing for this one. So this implies that we can have X being equal to, say, let's say X2 Z, Y equal to Y2 Z, and that the GCD of X2 and Y2 equals to 1. Okay. Now, because we have GCD of W and Z being equal to 1, so let's look at it. So we have basically W divides X and Z divides X. Okay, so based on the GCD statement. But the GCD of W and Z is equal to 1. So this implies, uh, this implies that WZ divides X. Okay, so very, very important. So let's look at it again. So if you have the GCD of two, so it's kind of similar to like some of the properties we discussed. If you have two numbers dividing a fixed number, so W divides X, Z divides X. So this implies basically, so a longer route to get to it would be that the LCM of W and Z divides X, okay? But the GCD of X and of W and Z is 1, so LCM of W and Z is equal to WZ, okay? So now let's scroll down a bit. Okay. So what does it imply? It means indeed we can have X, we can express X as let me just use a different alphabet. So means we can express X as AWZ, okay? for some A. And then I'll just express V as V1 W and Y as Y2 Z. Okay. So now we want to find the GCD of X and VY. Okay. So in this case, we have the GCD of X and VY. So when we put in the substitutions, so it is equal to the GCD of AWZ and V1 Y2 WZ. Okay. So basically, we want to get that this is equal to WZ, basically. We can see that WZ divides AWZ and V1 Y2 WZ. So now, if we can get that, so we just need to find the GCD of A and V1 Y2. So if we can get that this is 1, then we'll be done. Okay. So let's look at this. So recall that we have the GCD of the GCD of X1 and V1 is equals to 1. So X1 is actually equal to, so X1 is equal to A times Z, basically, based on how we define this. So X1 here is equals to A times Z. Okay. So it means we have GCD of A times Z and V1 is equals to 1. And then we have the GCD of X2 and Y2 being equal to 1. So Y2 is equals to, remember that X2 is equal to AW. So this is the same as GCD of AW and Y2 being equals to 1. So what this implies is that if you have the GCD of AZ and V1 being equal to 1 implies that if we reduce if we replace AZ with just A, because I mean A is a factor of AZ, the GCD is still going to be 1, okay? But GCD is less than or equal to this original one. So GCD is still going to be 1. Okay. Because 1 is the minimum value for a GCD, and similar thing here. So GCD of A and Y2 equals to 1. So now when you then multiply both cases, so basically we see that A does not have any divisor in common with both V1 and Y2. So it means A does not have a divisor in common with their products. And thus we have that this last statement here is true. So in fact, this is equals to WZ. Okay. So I just needed to make this video to clarify. I'm going to link this video to the original video, and yeah, see you in the next video. Goodbye, everyone.